Alright, so this is Chapter 10, Section 7, Areas of Circles and Sectors. In this section, you'll find the areas of circles, sectors, and segments of circles. So the really important component I wanted you guys to write in your notes when finding the area of a circle is the formula for the area of a circle, which is A equals pi times radius squared. So in this scenario, we are trying to find the area of this wrestling mat, and we are given that the diameter is 32 feet, and we want the radius. So if we take 32 and cut it in half, we get 16 feet. Okay, so all we're doing is taking our area formula, putting in 16 for the radius, and squaring it. So that is pi times 256, only because I have the square of 16 memorized. So if I were to put this in my calculator, I would go pi times 256 equals 804.24. So let's see if that matches up. Check. Alright, so next item up for bid, finding the area of a sector. So important here, area of a sector. A sector is not your entire circle, but just a shaded portion of your circle. So we're just going to be looking at this little green guy right here. The area of a sector, so write this down and keep it somewhere where you can refer to it again. And remember, when we have a segment, that's like taking a fraction of the whole thing. So the formula is always going to have a fraction in it. That's how I remember the formula. So if whatever our arc length is, so we want to find, we need the arc length, we need the radius, and then we can plug it right into the formula. So we get 72 divided by 360. This reduces down if you divide by 72. 72 divided by 72 is 1. 360 divided by 5 is, or sorry, divided by 72 is 5. And we are going to put in 15 for R. Simplify it down a little bit further. And we have 15 squared is 225. We're going to multiply that by 1/5. If you're not great with fractions, until you get to a place on a test where they say don't use calculators, which happens rarely, you can always do this on a calculator. You get 1/5 of 225 is 45. And so the area, it doesn't say, it says leave your answer in terms of pi, so that is 45 pi centimeters squared. All right, let's try this again, but with a different scenario. A circle has a radius of 4 inches, and I am always a fan of drawing the picture. If you don't draw the picture, then you're missing out on some good time fun. The circle has a radius of 4. Oh, that's a highlighter. Inches. And what is the area of the sector bounded by a 45-degree minor arc? So we have this arc here. We're going to grab the formula, which is our arc divided by 360 times 2. Pi times r squared. And so we're going to fill in, our arc is 45. Our bottom 360 times pi times radius squared. We're going to solve this down. I know that 90 degrees, if I'm here, is 1/4 or 1/4 of a circle. So 45 degrees has to be 1/8 of the circle. So this is equal to 1/8 pi times 16. So let's shuffle this around a little bit and go, this is 16 over 8 pi. 16 over 8, shall we know that? 2 pi. So leave your answers in terms of pi. So the answer to this is 2 pi inches squared. All right, so problem number 3, we're finding the area of a segment of the circle. So we found the whole circle, then we found the little pie cut out. Now we're just finding the area of this little sliver right here, little almond-sized sliver. So when we find the area of the sector, or area of a segment, it is the area of the sector minus the area of the triangle. Let's see where it is. So the area of the segment is the area of the sector minus the area of the triangle. So when we're working this through, we're going to find the area of the sector first. So the area of sector A, C, B. So this whole thing here. So it's our arc divided by 360 times pi r squared. So our arc is 60 degrees. Our radius is 18. We chug, chug, chug. This is 1/6 times 18 squared. And if you guys want to see how to do that in the calculator, you go 60 divided by 360 times 18 squared equals 54. And then the pi just hangs. Okay, so ACB is an equilateral triangle. The side lengths are, so your side lengths AC and CB are both the radius of your circle. So both side lengths are 18. When we have, if you look, here's a replication of that triangle up here. We have a 30, 60, 90 triangle. If the hypotenuse is 18, then the short side is half of that because the hypotenuse is twice the short side. And then our height is 9 times the square root of 3. And let me put up a 30, 60, 90 triangle for you guys so you can remember. This is something that has come up a couple of times. So I have a short side. I have a hypotenuse, which is 2 times the short side. That's for a 60, 90 triangle. And then my longer side is the short side times the square root of 3. So in this scenario, I have 18 as my hypotenuse. I have 9 as my short side because it's half of 18, and then I have 9 root 3 is my height of my triangle. Because in order to find the area of a triangle, it's 1/2 base times height. So my base is 18. And then my height is 9 root 3. So I know that half of 18 is 9. 9 times 9 is 81. And we're going to leave the square root of 3 as it is. So it's 81 square root of 3. All right, so let's bring this all together. The area of the sector we found was 54 pi. The area of the triangle was 81 root 3. We are going to subtract those two items. We're going to use our calculator. So we got 54 times pi minus, I'll put this in parentheses because I got a little squirrely around going on there, 81 times square root of 3 equals 29.349. So the area of the shaded segment, just this little sliver, is 29.3 square inches.